Hey guys, I'm Hannes from Arduino, and today I'm going to show you how to build a wireless basketball scoreboard that you can see here behind me using a Nano ESP32, a Nano connector carrier and 3 Modulino nodes, and we're going to be programming it all in MicroPython. For this build we need an Arduino Nano ESP32, a Nano connector carrier, a Modulino distance to detect when a ball goes through the hoop, a Modulino buttons to select the number of players, a Modulino pixels to show whose turn it is with colorful LEDs, some quick cables, and a USB-C cable to upload code and power the system. To organize everything a little bit nicer, I'm using the base plate from the Plug and Make kit. I also found this little basketball hoop in the office, and while it's not necessary for this project to work, it fits nicely and it's actually what gave me the idea to start with. Let's assemble everything. Place the Nano board on top of the carrier and connect the Modulinos using the quick cables. Then I'm using the Modulino base plate to organize everything so it can sit underneath the basketball hoop. This worked for me, so feel free to adapt it to your own needs. Before writing any code, we need to prepare the Nano ESP32 to be used with MicroPython. For this, I will use our MicroPython install tool that can be downloaded on Arduino Labs. Connect your Nano ESP32 to your PC. Wait for it to be detected and flash the firmware to the board. Once completed, disconnect and reconnect the board. We're also going to use our MicroPython IDE that can be found on lab-micropython.arduino.cc. If you don't want to use the browser version, there is a downloadable version available as well. Just keep in mind that all software provided on Arduino Labs is considered experimental software. Now let's break down the code from top to bottom so you can understand exactly what's happening and why. At the top of the script, we import the necessary libraries: network and socket for Wi-Fi functionality, Modulino for interfacing with hardware modules, and time utilities for delays and timestamps. We begin by disabling the default Wi-Fi station interface and enabling the access point mode. This lets the Nano ESP32 act as a mini Wi-Fi router. We set the network name to basketball score, and once active, the access point will allow us to connect devices and view the scoreboard in a web browser at the address that we've specified in the code here. Next, we create an instance of 3 Modulinos: Modulino distance to detect how close an object is, Modulino pixels to control the RGB LEDs, and Modulino buttons to handle input from the 3-button module. Then we set up a few global variables that track the current game state, including the number of players, scores, and timing for the bouncing input. We define a function called updatePixels, which lights up the correct number of LEDs based on how many players are in the game. There's also a dictionary that maps player counts from 1 to 8 to this function. And because we don't want our game to go on forever, we create a game over function that once a player has reached the player winning score, we light up that player's LED in a golden color. The main gameplay is managed by a function called runGame. This constantly checks the distance sensor. If something moves within the threshold and it's been more than 500 milliseconds since the last score, the current player is awarded a point, and the game rotates to the next player. If the player should miss, press the B button to move to the next player. We then define a function called makeHTML, which creates a very simple HTML web page showing each player's score and adds an arrow next to the active player. This HTML is served by the ESP32's built-in web server. The server is created with start server, which listens for browser requests and responds with our HTML page. Before the game starts, we enter player selection mode. This loop checks the buttons. Button A increases the number of player, button C decreases it, and button B confirms the selection. As players are added or removed, the pixel LEDs light up accordingly. Once the number of players is confirmed, the game begins. The ESP32 now enters a loop where it alternates between running the game logic and serving the HTML page to any connected device. Every 2 seconds, a heartbeat message prints to the console to let us know the program is still running. Once a player has reached the winning score, a display message is displayed in the terminal and on the web page. To connect to the scoreboard, open your Wi-Fi settings and connect to the basketball score network. You might get prompted that there's no internet available. That's fine, we don't need it. Just click yes. Once you're connected, go to your browser and specify the IP that we've written down in the code. You should see the scoreboard and each player you've selected in the beginning. You can see how each player might get their points, and once a player has won, it will say game over. And there we have it. A wireless scoreboard for up to 8 players with auto turn tracking, visual feedback with LEDs and a web UI to display scores in real time. And that's it. If you want to build this yourself, check out the links in the description below and find the full code and all the modules I used.